In the majority of videos and online discussions, we tend to focus on the physical attributes of our 3D printers, and we gloss over the control boards and, more importantly, the firmware. So that's going to be the subject of this video, but I know that some of you out there don't want to sit through 20 minutes about the nitty-gritty of all the ins and outs of the subject. So let me just give you the takeaways here. This is a Duet Wi-Fi, absolutely the best control board that you can get today for your 3D printer, but at $175, it pretty much doubles the cost of any printer that you're going to be getting from China. This is an MKS Gen L board. Actually, it's not, but that's the closest that I personally have to a Gen L. And it costs about $60, maybe $45 if you're really good at bargain shopping, to get all of the trinamic drivers that are going to plug into this board. And if you want Wi-Fi capability to match the Duet Wi-Fi board here, you're going to have to get a Raspberry Pi. And that is a 32-bit chip that's going to be sort of like talking to your 8-bit chip. So you're going to have to figure out how to install, Octoprint, which can be complicated, not that bad, but you're going to have to get Octoprint onto your Raspberry Pi, and then you're going to have to get a good Marlin build. That's the firmware, that's pretty convoluted, installed onto your actual 8-bit processor here. Now there is a new option which I haven't really gotten into, but it looks very promising, and that is called Clipper firmware. And that basically runs entirely on your Raspberry Pi, which then sort of like feeds a slow stream of data to your 8-bit processor, so this thing never gets overloaded. So that's kind of promising, but you're still looking at about $90, $95 for these two control boards on your printer. Whereas this board, the star of the show here today, the Duet Maestro, only costs $120, so you're only adding $20 or so to the cost, and you get to use RepRapFirmware, which is like, it's so worth the $20. I can't even start to describe it. Now, at the end of the video here, I'll give you guys a little sort of quick overview of RepRapFirmware, but let's just wrap it up here in the intro by saying that this board is everything that this board is except for Wi-Fi, but only for 3D printers. Everything about this board has been sort of downgraded, but this board is overbuilt for 3D printers. So this one is custom tailored for 3D printers, and I'm really impressed by it. So if you can connect your printer via a Cat5 Ethernet cable to your network in your house or your office, wherever you're 3D printing, then you will have all of the functionality from this board that you would get out of the Wi-Fi. So there's your TLDR. Now let's get into the nitty-gritty. At first glance, it may not appear to be the case, but what you're actually looking at here are two competing software ecosystems. So on the right, we have the Duet boards running RepRapFirmware. Now the software and the hardware have been developed in tandem, so this is just a really fantastic integration between the two, kind of like Macintosh computers used to be back in the day. So these are your Marlin-based boards. This is a Melzi 2.0 that was designed by a Western company that has since gone out of business, and this is the board that came off of my Ender 3, and it is the same. It's the same. It doesn't look like it just because the form factor changed it a little bit, but all the components are the same, all the functionality is the same. So those two boards, they're the same, and they're getting pretty old. 2012 is when that was designed, so yeah, I mean, think about other electronics that were designed in 2012, like the iPhone 5 or something like that. So this is just, and those chips, the last, when 8-bit chips were, cutting edge was like 1986, way back in the day. So this is just, I mean, yeah, it works. It's like a bare minimum sort of get it to work. It does run like a printer, but there's so many other things you want to do. You need the extra processing power. For instance, you cannot run a Delta printer even on this chip, which is the better chip than you find on these two boards. You can't run a Delta on this and run the larger screen, the RepRap discount full graphics display this size. There's not enough memory on the chip to be able to do both those things. So these are really just inadequate, and the reason we find them on printers these days is because China follows the leader. And the leader in the 3D printing industry for the last few years has been Prusa. And Prusa has a Rambo board which runs an ATmega 2560 chip and has trinamic stepper motor drivers on it. So Of course, and it runs Marlin. That's the key. It runs Marlin for the firmware. So China's going to run Marlin. It's the low-cost alternative. And yeah, plus, RepRapFirmware with the Duet boards is reasonably new. Marlin's been around for a while, but I predict that the future is these two boards, but we'll get to those here in a second. So let's first talk about if you do want to upgrade your printer, right? Most of us are going to find videos by all of the other channels except this one here that are going to kind of recommend an MKS Gen L board, probably. That's probably the most likely upgrade board today. And this is a Tri-Gorilla board that came off of my Anycubic console. I don't have an MKS Gen L board, but this one is darn close as far as specs go to the Gen L. It has an ATmega 2560, which has like twice as much memory as the ATmega 1284. It's got detachable stepper motor drivers, so those just unplug, and that allows you to upgrade. You can see that I currently have 3 Trinamic drivers. So 4 Trinamic drivers, each costing you about $10. That's $40. And then the Gen L, the MKS Gen L board cost you about $16. So you're looking at about $55. You might be able to get it for like $45 if you really shop around. So it's not cheap, but it's not expensive. I mean, it's the cheapest option, but it's not nothing. And if you want to get that to run wirelessly, like you want to send prints to it through your Wi-Fi connection instead of unplugging the SD card, from your computer, walking it over to your printer, plugging it in, and that's how you make the prints happen, you do have an option for wirelessly sending prints. You can install a 32-bit processor-based Raspberry Pi. This is a 3, and with this running Octoprint, you can run a webcam off of it and do Octolapse, which is pretty trick. There's a lot of little neat features there. I mean, it's kind of gimmicky. Most of us just want to print things. We don't want to take pictures of the prints as they're happening, unless you're a YouTuber. If you don't need to take the photographs, then you do have the much cheaper option of using the Raspberry Pi Zero W for wireless. And that's a $10 board. So you're looking at, what did I say, $50, $55 plus 10, so you're $65. So that's not too bad in price. Let's compare and contrast that with these two Duet boards. So the wireless version, that's the Duet Wi-Fi, this is all made in England, designed in England, and this is the very latest version with these 3 blade type fuses. So that's top of the line. And then this would be sort of bottom of the line as far as the Duet goes. Still, in a whole other ballpark from all this stuff. But yeah, so that's a 32-bit processor, just like that's a 32-bit processor. But this is, everything's been sort of downgraded, and it does not have the Wi-Fi chip. Instead, it just has a regular old Cat5 Ethernet cable plug-in. But both of these boards will allow you to run RepRapFirmware. Let's go straight to the source and get some information from the websites. So this is the Duet Maestro that we're looking at right here, and here is the documentation page, just lots of great information about it. Now, the Duet Maestro was designed by M3D, but of course they based all of their designing off of work previously done by the Duet 3D folks. And in fact, they heavily consulted Duet 3D. It's a complete partnership there. So it's Duet 3D is coming out of England, M3D is coming out of the United States. So Western designed control board that is produced in China. So that's why it's able to be, $75 cheaper than the full-fledged English designed, England made Duet 3D. So the Duet from England, you can get an Ethernet version or the Wi-Fi version. Everything is better about this board, but it doesn't matter that much if all you're doing is running a 3D printer. So the Maestro really sort of optimized for running a 3D printer. So there's that. Duet 3D, of course, has this fantastic forum right here on the Duet 3D site, and there's questions being answered about the Maestro over here, about RepRapFirmware. So this is just the place to go if you have any problems or are looking for solutions to anything related to the Duet boards. So I really can't speak highly enough about this forum. Okay, so the Duet 2 Wi-Fi is 120 pounds, which is like $175. So if you are located in the United States, I recommend purchasing your England-made Duet boards from Philistruder. You're going to save on shipping, so it'll be like $5 cheaper than if you get them through Duet 3D. If you want to buy the Duet Maestro, you get it from M3D, and I will include, of course, all of these links in the description. And hey, look at that. It's actually $20 more than I thought. I think the original, like if you were a Kickstarter backer or something, it used to be $100, but I guess it went up by $20. Maybe Trump's trade war is wreaking havoc on the price or something. I have no idea, but yeah. So the Duet Maestro, $119 versus the Duet Wi-Fi, which is going to be $175. So $55 price difference, which is, I mean, substantial. But let's look at the differences then to see where your bucks go. So here on this older Fit for Launch site, you can see the original price tag of $99. And there's also this great, side-by-side comparison of all the features between the Duet Maestro and the Duet Wi-Fi. But let's just go over the standout features to me, starting with the processors. So those are the names of those, if you can read that. Just a bunch of numbers and letters. But basically it comes down to the fact that they're both 32-bit architecture. The Maestro does not have a floating point unit, which is just this little computation unit in there, whereas the Wi-Fi does. Now the floating point unit allows it to do all of the math for a single movement of the printer in a single clock cycle. But both of these 32-bit processors are running 120 megahertz, which means 120 million cycles per second. So without the float point processor, this takes hundreds of clock cycles to make a movement. But when it's making 120 million clock cycles in a second, you're not going to notice that it doesn't have a float point. It's also worth mentioning that 120 million cycles per second is 10 times faster than the 8-bit boards. So you're getting 10 times the speed. So one interesting thing to note is that the Duet 2 Wi-Fi chip, even though it is more expensive and it does seem to be an upgrade, does have less memory at 512 kilobytes of flash memory instead of 1024 kilobytes of memory here on the Maestro. Moving on, stepper motor drivers. The Maestro has Trinamics, TMC 2224s, whereas the Duet also has Trinamics, but they're 2660s. So this is interesting because the 2660 board, or I'm sorry, the 2660 stepper motor drivers have basically twice the power. You can run really beefy stepper motors with this. With the 2224s, you're going to, of course, be able to control any steppers on any consumer level printer that we're going to be buying. So from your Creality Ender 3 to maybe the CR10S, the expanded big version, I mean, this will handle it just fine. But if you want to run like a CNC machine, you're going to want to get the Wi-Fi, the full-on Duet. Those are much beefier chips. Now, something that's interesting is that the upgraded, more powerful chip does not have the stealth chop function. Now, that's a technology developed by Trinamic that makes your stepper motors just absolutely silent in operation. But the problem with stealth chop is that it limits your torque. So it really encourages skipping of during prints. So it's no good. I personally have experimented with it and just was like, nope, I'm never going to use this. Even on just regular spread cycle mode, those stepper motors are just so much quieter than they are with like the old Polu A4988 chips. So the 2224 here, those chips on the Maestro have the ability to be run in stealth chop. So if you want to risk the skipping of the stepper motors, you can run your printer absolutely silently. So far, any of the features between these two that makes one or the other better, it's kind of a wash. It doesn't really matter as far as 3D printers go. Next, let's talk about expandability. So if you want to upgrade your 3D printer, let's say you want to turn it into some sort of a tool changer, I don't even know what, there's lots of options for upgrading. It's just super easy with RepRapFirmware. But the Duet Maestro really doesn't have as much expandability options. So let's just go into those. There's basically 2 additional steppers that you can put on there. So I think it comes with 5 steppers, so you can get 7 total, whereas
you can put 7 additional steppers. So it's 5 plus 7. So you're looking at 12 stepper motors that you can run with the Duet Wi-Fi. So just a whole lot of expandability there. In the stepper motors, there's also more GPIO pins, like significantly more. So you can run a whole lot of other peripheral things, lights, LEDs, that kind of a deal with the Wi-Fi that you can't, because there's only there's just fewer GPIO pins. I'm not going to get into it. You can go figure out the specifics if you care. They're on this page here. There's only support for 1 servo here on the Duet Maestro, and that's pretty much all you need for running the Ant Collab's BL Touch sensor, which I love. I love that that bed leveling sensor. With the Duet Wi-Fi, you can run 5 servos. So this, like I said, the expandability is just way better on the Duet Wi-Fi. Now let's talk about, I think, the biggest difference between these two boards. The Maestro is designed to be able to handle an LCD, the what is it called? The 12864 monographic display. That's also known as the RepRap Discount Full Graphics Display. It's the larger, screen that you're typically going to see on these printers. It's the screen that came on the Ender 3, for instance. There is the potential to put it onto the Wi-Fi, but you're going to have to make sort of a little bit of custom wiring, or maybe I'm sure somebody soon will be producing a PCB that allows you to just plug that LCD in, but it's not designed to do it straight out of the box. Whereas with the Maestro, it's pretty much plug and play. You plug it in and it's going to work. And I'll show you guys that here in a minute. But the final thing to sort of note as a difference between the Maestro and the Wi-Fi is just that the Duet Wi-Fi, they went to great lengths to make it the absolute best that they can make it. I can't say enough good stuff about this design and this production. So made in England to be idiot proof, as much as you could make something idiot proof. I'll link to a blog post from Duet in the description that talks about just how much effort they went to make this board. Just, you can't break it. If you're just a reasonable newbie, they try to remove every pitfall for you and just make it a very seamless, easy thing to use, which is absolutely the opposite experience that anybody's ever had trying to run Marlin on one of those 8-bit processors. And it gets even worse when you're installing Octoprint and getting into all that complication. By the way, there is a question that people have about running Octoprint on the Maestro. So can you plug a Raspberry Pi Zero W, for instance, for $10 into the Maestro and suddenly get all the Wi-Fi capability? Well, no, basically. Now, I'm sure somebody's going to find a way to make it possible, but listen, these are two different ecosystems. Duet Wi-Fi has integrated the wireless functionality into it just seamlessly into the RepRapFirmware. Whereas when you're running Octoprint on top of RepRapFirmware, it's not going to be pretty. And I haven't seen anybody successfully doing it online I didn't search that far and long, but from my quick searches, there's nobody doing it. And it's not something that Duet is trying to make happen. So Octoprint goes with Marlin.
Before I started making this video, I posted a teaser image of these two boards side by side, and I asked all of my subscribers, well, probably just the guys who have rung that little bell are the ones who saw that post, but I asked you guys what you wanted me to talk about or if you had any questions. So starting with Laser Jovic, he left a comment talking about using external stepper motor drivers such as DM556. Now these will give you the ability to control large CNC routers, very powerful motors on the CNC routers. And you can use a Duet to control that CNC router. So very cool stuff. And Laser, if you are watching this, you should totally make a video or a Reddit/Imgur post about this process, and I will give a shout out to that post when you send me a link. So Chris Sorensen asked if you can use either of these boards with closed loop steppers. Now, in case you don't know, closed loop steppers are just some pretty fancy motors. They're stepper motors with a rotary encoder. So you tell them where to go precisely. That's the stepper motor functionality, and the encoder double checks that movement. So theoretically, this guarantees that you won't have any more skipping issues or layer skipping, whatever issues. Your prints will be perfect. So installing these stepper motors is roughly the same process as what Laser Jovic did with his steppers. And there's also a write-up on the Duet 3D forum, so I will link to that in the description if you want to get those sorts of things running on your printer. Okay, 23 Midway 23 wants to know about putting Clipper on the Maestro. So this is the Duet Maestro, and he wants to run Clipper, but I'll tell you what, it's not going to work. I'm sure somebody could hack it, maybe, I don't know, but Clipper is designed to work on a Raspberry Pi and control the little 8-bit, ramps-based boards. So 2 different ecosystems here. I'm just going to say no, you will not get Clipper to work on the Duet. Jack Matheson said, quote, "I think most reviewers just gloss over how insanely programmable the Duet boards are." Now, you are so right, Jack, and let's talk about that here right now.
So this is the interface to my wireless router. There's the Maestro connected via Cat5 Ethernet cable. So the next tab here in my browser is my interface with the Maestro. Really cool, really just super user-friendly. Here's your machine control tab where you can like home the printer, you can do auto bed compensation, you can send G-code commands from the G-code console here. You can do all kinds of stuff, right? G-code files, let's upload a file. You just click on that button and you upload, something that your slicer made. So that's just your general usability. You don't ever need to use that screen. And as I talked about earlier, you actually cannot use the micro SD card on the screen to upload G-code files. You have to do that through this interface right here. But let's say you want to change something with the firmware. Well, if you want to upload a whole new build of the firmware, the configuration build, you would just click this button right here, the upload files. So you could get the entire configuration from me for the Ender 3. Just click that button, boom, you're done. It's going to work. So, if you want to get into sort of more detailed editing of the firmware build, you can go here to System Editor and let's look at config.g, for instance. Here's an M918P1E-1, and that is how I set the screen to work. So that's just a G-code command, part of this macro. And now the macros run everything. So these are all just macros. The actual firmware, you're never going to touch it. It comes pre-flashed, and you're never going to have to know the programming language to modify this. It makes a whole lot more sense intuitively because you're already dealing with G-code. You're doing 3D printing, so it's just a bunch more G-code commands. Here's the macros button, and if we click that, we can see, well, these are the ones that came stock. Now I need to actually set this up on my printer, and you'll see that in the next video. I'm really going to go over exactly how to get this to work on an Ender 3. But yeah, let's just say we're going to edit the test heaters, right? So this is a macro, user-defined macro, and it's just going to run through all of these commands. And this is something that they were doing at the factory just to make sure that the board was fully functional. We're not going to modify it, but what you can do is go back to machine control, and you see here on the right, we've got user-defined macros, and there's test heaters. So if I clicked that button right there, it's going to run all of that, all of those commands. So it's insanely easy. Just like Jack said, it's, you can have a button right here for turning the LED light on your printer on and off. You can have a button that, I don't know, the sky's the limit. Whatever you think that you want your printer to do, you can control it right there. Just very, very customizable. There's the Maestro connected to the Ethernet to the router through this Cat5 cable. It's being powered by that 24-volt power supply, and we are controlling it with this RepRap discount full graphics display, the 12864. And yeah, it's pretty fantastic, right? So it's worth noting that this screen, the RepRap discount one, will work. It's what it's designed to work with. But the Ender 3 screen, which looks like it should be the same, does not work. It's just different enough in the electronics that it's not compatible. So I think that means that any Creality screen is not going to be compatible with the Maestro right out of the box. You will have to get one of these. They're pretty inexpensive though, and it looks like the screw pattern I think is the same. So I think that will just mount right in place there. So you shouldn't have too much of a problem, but you do have to buy that bit of hardware. Now the AlphaWise U10 has a different layout. See the knob compared to this one where the knob is below, that knob's on the side, but that screen, that's compatible. So I tried this out and it works just fine. So if you have an alpha-wise printer, it's a little easier to get it to work. Now, a little bit of criticism, the screen I currently have set up to be 1 click equals 2 menu items. So watch, I'm going to turn this to the right and it's going to skip the control and go to print. So yeah, so you can get to the control menu there by going half click, but it just takes a little bit of finesse and it's not easy. It's easy to skip over. So there's a way to control that in firmware and to flip it so that 1 click equals 1 menu item movement, but it glitches out. So there we see it, that whole bar is sort of being glitched out, and if I try to move, you see it selects 2 items at a time. So that whole bar is it's basically selecting 2 items at a time, but I'm moving 1 item at a time as I move through the menu. So I don't know what the incompatibility there is. I don't know whether to blame the screen or the board. Probably it's the fault of the board, because you can probably get it to work better if you wrote that library that controls the screen a little bit better.
That is my Ender 3, and if you've been following along with the build series, you'll know all the specs of that thing. It's running fantastically. I've got like 50 hours of printing on it with the board here inside of that green case being cooled by the single large fan that also cools the power supply, and a ton of other upgrades. Watch the video. So in the next video that I make here, we're going to do a similar treatment to the Ender 3 Pro, but this time we're going to use the Duet Maestro. And it's an interesting sort of thing because I'm basically using the cheaper board, the Duet Maestro, on the more expensive printer. So the money you save on the board, you're going to spend on the printer. So basically, you could have either one of these for a similar cost. But this is going to be a much lighter weight intervention. I'm going to install the Duet Maestro into the case that currently houses the stock hardware, the stock control board, and the screen's going to mount right where it currently mounts. So except for all of the cooling fan stuff, it's going to look pretty much like a stock printer when we're done with it in the next video. So tune in for that one, ring the bell, subscribe, that kind of a deal. And please give a shout out, give a thank you to all of these wonderful folks. These are my monetary supporters, and without their help, I would not be making videos for you guys to watch. So that's how that works. All right, well, that's it for this video. Thanks for watching. See you next time.